Hi friends, this new framework from Amazon took a more fine-grained approach based on claims for evaluating the RAG systems compared to the existing frameworks. First, let's understand what a claim is. Alright, so here is the prompt to an LLM to extract the claims from a RAG system, right? Which includes the context, the question, and the produced response. Okay, so from each one we can extract the claims. So basically a claim is a piece of knowledge in the response. Okay, piece of knowledge point. Now claim should be fine grained and one claim should not contain more than one piece of knowledge. Okay, claim should be self-contained and is not dependent on other claims. Okay, and each claim should truly reflect the meaning expressed in the response, so on and so forth. And also the opinions, speculations, or questions in the text are not claims. Okay, I hope that gives you some clarity on what a claim is. So given a RAG system response, the framework, it first extract all these claims, and based on those claims it evaluate the performance of both the retriever, the generator, and compute some overall metrics. All right, so uh, let's look at this diagram now. So in this red portion we have the ground truth. Let's say for all these questions we already know what the actual correct answer is. Now for easier understanding, let's say the question we asked is something like, how do I open a bank account? So there is a step-by-step instructions, right? So there are let's say 6 pieces of claims in its ground truth. Okay, so let's say these 3 and these 3, or the question could be something like, how do I go from place A to B? So let's say there are 6 steps involved and these are those 6 steps. That's our ground truth. And then here we have the model response. Now the model response, it could contain some incorrect ones, right? So here there are 7 claims in the model response, out of which 3 match with the ground truth, meaning they are correct, and we have 4 claims which are not correct. Okay, and then here we have the chunks. So we have 3 chunks. As you know, the chunk, it can, one way to think about chunk is, it's a, let's say it's a paragraph, and each paragraph can contain the correct claims, incorrect claims, and irrelevant claims, right? It can contain a variety of information with respect to the given query. Okay, so that's what we have within those 3 chunks, right? So just to repeat, the circles, these are the correct claims, and the triangles are the claims, these are also correct, which are in the ground truth but not extracted by the model in its response. Now the cross, these are the claims produced by the generator but not relevant to the query. And then here we have the chunks. So the question mark, that represents some irrelevant claims. All right, let's look at the overall metrics. So we have the precision and recall. This is similar to a classification system. So the precision means out of all the claims extracted, how many claims are actually correct. So the model response, it contains these 7 claims, right? So all those correct ones and the incorrect ones. So we have total 7 claims, out of which 3 are correct. So the precision will be 3 divided with 7. Okay, and then the recall would be out of all the claims which are in the ground truth or which are supposed to be generated by the generator, how many of them are actually recalled or generated by the generator. Okay, so out of these 6 claims which are supposed to be there, which is what we have here, so the triangle and the circles, the model has generated only these 3 claims. So our recall will be 3 divided with 6. Okay, now let's look at metrics specific to this retriever. All right, so here we have these chunks. These are these chunks based metrics. Now the context precision, so this is at a chunk level. Okay, so here we have 3 chunks extracted. Out of these 3 chunks, only 1 chunk is relevant to the query we have, so the precision is 1/3. All right, then we have the recall, but notice that this recall is at the claim level, not at the chunk level. Okay, now so here we have all the claims which are supposed to be there, circles plus triangles, out of which how many of them are in the retrieved context. Okay, so for example, here the context has both these circles and the triangles, right? So which are in this green chunk. These are all extracted, right? However, the model has missed, or the generator has missed, these three claims in its response. Okay, so the recall is what's available or what's been extracted in the chunks divided with what's supposed to be there in the generator. Now these ones a little tricky, rather than somebody explaining. If you take your time and just think about them slowly, you get much more clarity. All right, now let's look at the generator metrics. Now here we have 5 metrics, out of which 4 of them, they have the same denominator. So first let's look at them, and then we'll look at the first one. Now there is some ambiguity. Now I looked at the research paper. In the definitions are slightly different in the research paper, or these diagrams. So I'm not sure which one is the latest. I'm going by what is there on their GitHub page. Assuming they probably corrected after publishing the paper, or it could be the other way. All right, so the denominator is what has been generated by the model, right? So all the circles plus all the crosses, okay? All the circles plus crosses. So for these 4 metrics, the denominator is what has been, or the claims which are generated by the generator. Now let's look at the hallucination. So the hallucination means something which is cooked up by the generator, right? So something which is not in the provided context, but it is there in the generated response, okay? So if you see, these are all incorrect claims produced by the generator. Now, out of these incorrect claims, which ones are actually not in the extracted chunks, okay? So this X not belonging to. So notice this is not belonging to, it's not belonging to, okay? So these incorrect claims which are not in the chunks but still are generated by the generator, okay? Out of all the claims generated by the generator. All right, that's hallucination. Now the self-knowledge. Self-knowledge means something which is not in the retrieved context, but the generator has generated it. So even though this information is correct, but it is actually not in the provided context. Now from a RAG system, we expect the response to be grounded in the provided context, right? So even if the model has answered the question correctly, but if that correct answer is not actually based on the provided context, that means the model has self-knowledge of it. But let's say we asked a too generic question, what has Einstein invented? Now we provided some context which is completely not related to Einstein, right? But the model still be able to answer it correctly because it has this self-knowledge, okay? So that's what we have here. So the correct claim which is not in any of the retrieved context, okay? So that's what this self-knowledge refer to. And then the faithfulness represent how grounded the generated claims are on the extracted chunks or the context, okay? So the generated claims, here we have circles as well as cross, are the correct ones or the incorrect ones. So the correct ones and the incorrect ones, how many of them belonging to the retrieved chunks as compared to all of them which are extracted, okay? So if all these 7 are actually based on these chunks, then the faithfulness score will be high, which is equal to 1, right? Whether they are correct or not, that's a secondary thing, but are they actually in the retrieved context, that's what this faithfulness computes. And finally, context utilization, which represent, so we have all this context which has a bunch of claims. Now out of those claims, what percentage of them has been utilized by the generator, which are actually relevant to the correct answer, okay? So the context utilization. So the correct ones, circles from the context, and all of the claims in the retrievers, okay? So here notice that both the circles and the triangles are the correct claims, and those are in the extracted context, right? So these are all the claims, all the correct claims, but out of which the generator is able to extract only these claims, okay? For example, let's say in this context, in this chunk, we have 5 circles and 5 triangles, okay? So we have total 10 claims. Out of these 10 claims, 3 of them has been extracted by the generator. So that would be 3/10. Now there is a little bit of ambiguity in these definitions. For example, if you look at the hallucination, so here, even if a response is correct and not based on the context, we would still call that hallucination, right? Whereas here in this definition of hallucination, in the numerator, we are only looking at which ones are not correct. So which ones are not correct, but it could be that we have the correct claims, correct with respect to the query, but still those claims are not coming from the retrieved context. Okay, so there is a little bit of ambiguity because we can have so many variations, but I think it's a really good step. We are evaluating at a much more fine-grained level as the library claims. All right, using it is super simple. So here, so from RAG checker, we simply import RAG results and RAG checker, and then we saw a bunch of metrics, right? I mean, by default, we can compute all the metrics, but it is up to you. We can choose a different class of metrics, like only retrieval related, or we can mix and match, etc. Right? Okay. Once we create a RAG system and run a bunch of queries through it, we need to prepare the data. Now I'll show you how it should look like. All right. So here is the results from RAG. We have two queries. Now first, here we have some query ID. Let's start with 0. So we have the query, and then we have the ground truth answer. Okay. So for example, when we talk about claims, so the Nile is a major north flowing river in Northeast America, right? This could be one claim, right? It's self-contained. It's not opinion. It talks about a piece of information, right? So where does it flow? It flow in the Mediterranean Sea. Now, it's not like each sentence is a claim. Sometimes we can have irrelevant, too generic information, which is not a claim. And sometimes a single sentence can have multiple claims as well. Okay. And then here is the RAG generated response. Now we have the retrieved context, which is a list. And here we have 4 elements in this list. Each one has its ID along with the context. Okay. So that's one RAG query. Okay. Similarly, here we have another query, ground truth, and the response. And this time we have 3 context is. Okay, so that's how we need to prepare the data. So once we prepare the data, just read the JSON file. And as we discussed, first we need to extract the claims. So here we have an LLM for extracting the claims, and then we have an LLM to verify or check those claims in order to compute the metrics. Now in this case, we are using the same model. All right, and then instantiate the evaluator using this RAG checker. Simply provide the 2 LLMs. We can provide a bunch of optional parameters like batch size, etc., but those won't change the results. And then compute or run the evaluator. We just need to supply our RAG results along with what metrics we want to compute. All right, so as we saw, we have 2 RAG results or 2 queries. So first, it try to extract the claims. Where is it? I think it's been some cutoff. So some extract the claims, and then it check the claims from the generated response, from the response to the chunks, etc. So this is how the results look like. So we have overall metrics, the precision recall, and based on which F1 score is computed. I think it's just the harmonic mean, and then the retrieval related one, the recall and claims recall and context precision, and finally we have these generator metrics which we saw. What else? That's pretty much it. I think it's a very good library. And by the way, here is the research paper. As I mentioned, their diagram is slightly different. As you can see from here, they don't have these incorrect chunks, something like that. Yeah, that's all for this video. Thank you very much.